These are the sources we used for this video about microwaves. The Microwave Presentation by Garrett Nixon and Hunter the last name. Microwaves are electromagnetic waves. Their frequencies vary between 0.3 gigahertz to 300 gigahertz. The frequencies go about 3 billion cycles per second, and their wavelengths are from 12 inches to 0.12 inches. The region divided and designed as L, S, C, and X. Electromagnetic radiation is transmitted, and different wavelengths and frequencies happen. Microwaves can be used for air traffic control towers, radio, communications, anything to do with radar, cooking, microwaves that cause the molecules, the water to vibrate, and mobile phones. The drawback of mobile phones is that they are small and they can't put out that much power. They also need a straight line of sight to be transmitted. Fixed cameras, mobile infrared, fixed traffic speed cameras, and most radar works by echo like bats. And fixed speed cameras use microwaves and the microwave to cook your food. As you can see, the bat is using waves to see. By echoing it off the object, when it comes back, it knows where it's at, like sonar. The existence of the radio was thanks to James Clerk Maxwell by his equations he did in 1864. In 1888, Hendrik Hertz was the first to demonstrate the microwave using spark gap radio transmitters. He used primitive equipment, which as a horse trot, wroughten iron point sparks, and London jars. In 1894, the first public demonstration of the radio control was by an Indian radio pioneer. He used millimeter wavelengths and helped spear research of the microwave. Trials with wavelengths low as 18 centimeters were known as undistinguished surprised. The problem of the microwave have been solved so early. In 1943, a Hungarian engineer, Zoltán Bay, sent out a short radio wave to the moon and back to find the distance of the moon, which was also used to study the moon. First use of the word microwave was in space relation context in an article in 1946 by Robert Dicke and Robert Berger. In the history of electromagnetic theory, significant work has been worked around microwaves and their applications carried out by researchers including James Clerk Maxwell in 1846. Later that year, Clark developed the theory of light, and the magnetic field could travel at the speed of light. His theory was later found to be true, starting electromagnetic waves, including radio waves. In 1886, a man named Hendrik Hertz tested this theory by switching electrical currents high to low rapidly, transmitting current through a conducting wire. Hertz was able to create waves now we call radio waves. In 1935, Robert Watson experimented with higher frequency radio waves, which later led to a patent. After World War II, the microwaves were now be allowed to used by non-military companies in the United States. Other companies began to look at new technologies and uses for the microwave. In 1943, communication towers were built by Western Union, AT&T, and others. The first company to send data from a telegraph wirelessly was Western Union. They sent stuff out wirelessly by having a series of repeating towers spaced out by 30 miles apart. The microwave's uses of cooking was discovered by accident whenever Dr. Percy Spencer was working on a communication tower and it melted his chocolate bar. With later discoveries, it could cook things with water in it. Microwaves are used by NASA and other space junkies because they're good for communication with narrow and focused bands, travel in a straight line, and can penetrate the atmospheres of Earth and can travel long distances in space. In 1959, U.S. naval engineers discovered that the microwaves could bounce off stuff in space. They were able to bounce a microwave message from Washington, D.C. off the moon to a place in Hawaii. The Federal Communication Commission, FCC, set up a reserved microwave frequency of 250 megahertz. Microwaves are also really good for cooking things. Today, I'll be teaching you how to find velocity, frequency, or a wavelength in a wave. So, first thing is first. I use a formula triangle because it shows everything. Less space, less time. You multiply frequency times by wavelength to find velocity, and velocity divided by frequency to find the wavelength. First thing what you will do is you will read the question. The wavelength is 0.01 meters, and the frequency is 2450 megahertz. What's the velocity? So first, I pull down all my numbers, and I will plug in the frequency and the wavelength to find, and then I'll multiply them together to get 2.24.5 meters per second. When finding the wavelength, when finding the wavelength, what you want to do is you would want to divide the velocity over the frequency according to the triangle. So, first thing is first, equals wavelength. Cool. So now I will plug in my numbers. 25 over 2450 megahertz. And then that together would be 0.010. So I'd just round it to the second number to be 0.01 meters. And thank you for watching, and have a nice day.